So this is LeetCode 404, sum of left leaves. Here we're given the root of a binary tree and we're told to return the sum of all left leaves. A leaf is a node with no children. A left leaf is a leaf that is a left child of another node. So this is going to be a walkthrough of this problem that I haven't solved. Just working through the process. So right off the bat, I'm thinking the strategy would be to go through every single node, and if that node has a left child, you add it to a sum. To do that, you could do breadth first search. I think that's what I'm going to do. So here we have instantiate an int, which is going to be a sum. It's going to start at 0. We're also going to want a queue of tree nodes. Then from here, we're going to want to do, we're going to want to check if the root equals null. And if it's null, you just return, what does it want to return? Let's just say 0. So I could say sum, that's probably more right. So now to do the breadth first search, you're basically going to add each node, and you add each of that node's left and right child to the queue, and until the queue is fully empty. It would be fully empty at the very end when all the nodes have no children. That's when stop. So here we're going to want to have a while loop, while queue dot. I'm going to want to see while the queue is not empty. While it's not empty, we're going to basically go through here. So we're going to say we're going to do a for loop for int I equals 0, I is less than queue dot size. That size is probably going to be expanding too, because we're going to be in this for loop, we're going to be adding to the queue, so that size will keep could get bigger and bigger. So we're going to want to set the size is equal to queue dot size. Then here we just say it's equal to that variable. So this will iterate through the queue one full time, and this is going to be for each level in the tree. So from here, we're going to want to have a tree node, which is the current node. That's going to equal to the queue dot move. This is going to be equal to the each leaf that we look at. So basically now we're going to be at each of these nodes, these leaves. From here, we want to check if it has a left child, and if it has a left child, we're going to add it. We're going to add it to the sum, and we're going to add it to the queue. If it has a right child, we're just going to add it to the queue. So we're going to say if current dot left not equal null, we're going to say sum equals the current left dot val. We're going to add it, and we're also going to add it to the queue. Push. We're going to also say if current dot right isn't null, if the right node's not null, we're just going to also add it, but we're just going to add it. We're not going to do anything else. Just push it. So I believe this would just work. So you remove it. That current node equals that. From there, we check the left and right. If it has a left, you add it to the sum. Else you just continue. And you just do that every single time. Let's see if that's right. Is that q dot add? Oh, wait. Is it q dot add? Root. We're gonna add the root. I think this is right. I think I just have the syntax wrong. All right. So here we're getting 6. Why are we getting 6? For which test case? Okay. I think we're passing the test cases. Yeah, we are. So if you have a root 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Why would this not work? Let's see. So we have the q, because adding the left, then we're adding the right. Left size, I is less than size. Is that? Yeah. Left, right. Oh. Well, yeah, it is checking that. So I think we're just adding one too many of these. I wish it would give us a picture. Current dot right, current dot right. So while q is not empty, yeah. It's for each row, adds. Sum plus equals the val of that. Left leaves. So that leaf also has to have no children. So that's tricky. We're also going to have to check if current.left equals null and current dot left dot right equals null. Then we're going to do the sum. Regardless, we're going to do this. I think this is right. Yeah, okay. So it wanted, so that beat 100%. It wanted left leaves. So a left leaf would be, let me see if I can get this extension. Works. So a left leaf would be it, meaning that this leaf here, the 9, that would technically be a left child of 3. It has to be a left leaf as well. So it has to be a left child and it has to be a leaf. A leaf has 0 children. So this 9, it doesn't have a left child and it doesn't have a right child. So it's a leaf. And it's also the left node of 3. So let's say it was 3, then 9, and then 9 had a left child of like 5. Technically, you're not supposed to add 9 to the sum that we have here, because 9 would not be a leaf. A leaf would have no children. But the 5 that we had down here would be a leaf, and it's a left child, which are the 2 cases that we're looking for.